I'm Steph Evans from Evotech, partnered with MSC Software. Here's another one of our MSC Apex quick bites, this time looking at how to create a stiffened panel. Okay, so we're going to start looking at a typical aircraft structure stiffened panel. So we've got some CAD geometry here that's been brought in. Many of you will be familiar with this type of thing. So we've got skin, stringers and frames. So we're going to create a very efficient means of FEA modelling this stiffened panel with a mix of 2D shell and 1D beam elements. Okay, so first of all we're going to create a mid-surface that represents the skin and then move that mid-surface into an FEA part placeholder. So you can see that here. So we've got the plane surface geometry. Just going to show the strings and the frames. So these regions, shown in blue and green here, are going to be represented by one-dimensional or 1D beam elements again. So we need to develop the topology or the geometry to allow us to develop, to create the mesh in that manner. Okay, so we're going to split the surface first of all based on these stringer locations. So we're using the split plane operation to break the surface up into one bay, as it were, between these stiffeners for the stringers and the frames. Okay, so very quick to do that in Apex just by picking those locations and then delete the surfaces that we don't want. So we can see we're developing the bay for those single regions, and then we're going to transform those bays around for the full fuselage structure. So splitting about the frame planes now. So again, picking the surface and picking 3 points on the mid edge, if you like, of this frame. Picking 3 points and then middle mouse button to accept, and we've got the split as we want. Okay, repeating that for the second frame plane. Picking 3 points on this mid edge to perform that split. Okay, and then we're going to delete the bays that we don't need just by highlighting and deleting those. So we've got this single bay. We're now going to transform or rotate and then translate this bay position to give us the full surface definition for the fuselage with the splits that we need for the stiffener locations. So just moving the translator to the magic marker of the surface arc and then rotating that round by a known angle, 10 degrees in this case. We've measured the geometry beforehand. I'm just going to repeat this a couple of times and then rotate to give us the full definition for the fuselage, full 360-degree definition. And then we're going to translate these surfaces out along the axis of the fuselage to give us the full definition. Okay, so just using the transform tool, moving that by, again, predetermined distance that we've measured from the original CAD geometry. So we've got multiple bays now that represent the surface between adjacent stringers and frames. Now stitch those geometric surfaces back together. So it's now one surface split at these the green lines that we saw there. They're shared edges between adjacent faces, and then meshing the surface in the appropriate element edge length. So we can see the mesh definition that we've got. And now we're into defining the 1D definition. So first of all, we need to make sure that the stiffener offsets are correct. So we're going to switch the element orientation, reverse it so the element normals are pointing inwards, as we can see. And then we're going to go into the 1D curve mesh generation. So meshing the edges of those adjacent or those stitched faces. We can see the 1D elements in there. And now we're into the 1D beam section definition. So we've picked out this eye section and then populated that with the dimensions that we've measured previously. And it's a case of assigning that section as a stiffener, the appropriate orientation to the regions in the model that reflect frame geometry first of all. So we're just picking out the frames, middle mouse button to accept, pick the edges and the surface, and we can see the frame sections that we've defined. Repeating that for the stringers. So we need the internal edges now. So just picking all the edges and then removing the frame edges that we don't want from that selection list. Okay, and then we can just create those stringer sections in a similar manner. Okay, green tick to accept, and then we're done with those sections. Okay, so really quickly and easily defined from the original geometry. We've got the spans in the model browser. We can switch the colours for all the spans or individually as required. And then overlaying the CAD onto that geometry, we can now see the overlay, how those 1D sections relate to the underlying geometry. Okay, so with the FEA model built, we've just run a buckling case here. We can see the eigenvalue for the first buckling mode, strain energy plot, and we're done. Super quick and easy.
I hope you found this interesting. If you'd like to develop your Apex usage, head over to our site where you'll find many online learning opportunities.